So in this unit, we're going to go over quadrilaterals. And so today we're going to go over section 1. And so our objectives are to prove and apply the properties of parallelograms and using the properties to solve problems. So first of all, the properties of a quadrilateral, first of all, it's a polygon with 4 sides. And then the sum of the interior angles of all quadrilaterals, which are a 4-sided polygon, are 360 degrees. And in this unit, we're going to go over a variety of quadrilaterals. Today, we're going to cover the parallelogram. Remember that the opposite sides of a quadrilateral do not share a vertex and the opposite angles do not share a side. So we're going to talk about that a lot today. So first of all, a parallelogram. When we're talking about a parallelogram, both pairs of opposite sides are parallel. To write the name of a parallelogram, you use the symbol, the parallelogram symbol. To name the parallelogram, you list the sides in consecutive order. So if I was trying to name this parallelogram, I would name it parallelogram. Yeah, it'd be good if I could draw, huh? Parallelogram A, B, C, D. So that is one way to name it. I could start with any letter and move in any direction. I just have to choose the thing that's right next to what I chose as I'm moving around. So I'm moving in consecutive order. So here, both pairs of opposite sides are parallel. So we're going to say that AB is parallel to CD, or DC. And then we're going to say that BC is parallel with DA. These are our parallel symbols. So both pairs of opposite sides are parallel, and if that's the case, AB would be parallel to CD, and BC would be parallel to DA. The next property is that both pairs of opposite sides are congruent. So we know that congruence is indicated by tick marks, so we're going to say that these opposite sides are congruent with our tick marks. So that would mean that AB is congruent to CD, and that BC is congruent to DA. Our next property is both pairs of opposite angles are congruent. So here we would have that angle A is congruent with angle C. These are our opposite angles. And that angle B is congruent with angle D. And once again, we would write a statement A is congruent to C and B is congruent to D. Our next property is consecutive angles are supplementary. So we have to look at what this word consecutive means. So it means if we're looking at consecutive, then if we're looking at A, then B would be consecutive to A, and so would D. So both pairs of these consecutive angles are supplementary, and the term supplementary means that when I add the angles together, they equal 180 degrees. So let's just put some measures in here. So if I told you that A was 75, then B would have to be 180 minus 75, so it would have to be 105. The same would be true of D because, again, it would be 180 minus 75, so that would also be 105. So what this property tells us is that when we add angle A to B, it equals 180, and we add angle A to D, it equals 180. So the consecutive angles, both consecutive angles to A are supplementary, thus it's a parallelogram. Okay, then our diagonals. Diagonals bisect each other, and recall that diagonals are going to go from one corner to the opposite one. So we would have diagonal AC here, and we would also have diagonal BD. Now I'm going to put a letter in the middle here and call it E, so that we can talk about what these diagonals. Now if a diagonal bisects something, it means it cuts it into 2 equal parts. So I could say that BE is congruent with ED, and I'm going to put 3 ticks here because we've already put some on the drawings that we have on our notes. And then AE, we're going to indicate that with 4, is congruent with CE. So our diagonals bisect each other. So BE would be congruent with DE, and AE would be congruent with CE. So now we're going to use these properties. So in number 1, the first thing I like to do is talk about what we know. So we know the opposite sides are congruent, so we're going to go ahead and mark these. And then I'm going to go ahead and put these measures here. Then we also know that opposite angles are congruent, so I'm going to work that. And now I need to find A. Well, to find A, I'm going to do 180 minus 68 and that's 112. So now I know the angle A is 112, and we know that A is congruent with C. So this would also be 112 down here. So then we can just write our answers in because we have them all sitting there. 8 and 15 here, 112 for A. We have 68 for B, and we have 112 for C. Okay, let's go on to number 2. So go ahead and work this problem and then come back to me when you're done. So here again, we have our opposite sides are congruent. So I'm going to transfer some of these numbers. We have that opposite angles are congruent. So this would also be 127. And then we need to say that our consecutive angles are supplementary. So when we do that, this would be 53 degrees because I subtracted 127 from 180, which means this angle would be congruent with this angle. So this would also be 53 degrees. So once again, now all I have to do is fill in my blanks. This would be 21, 29, 127 degrees, 53 degrees, and 53 degrees. Okay, the next one is a little different. The next one has to do with our diagonals. If my mouse is going to let me go to the next one. Okay, and our opposite sides. So here again, we're going to put some tick marks on our opposite sides. So I know that this is 27 down here and this is 18. The other thing I know is that my diagonals bisect each other. So I know that this one right here is congruent with this one. So if the bottom one, if UV is 7, then VS is 7. And then we also know that these are bisect each other as well. It tells us that RT is 30. So RT divided by 2 would be 15. So that means this one right here would be 15, and this one right here would be 15. So now once again, we have everything labeled, so all we have to do is fill in our blanks. So this would be 27, ST would be 18, VS would be 7, and BT would be 15. Okay, so for number 4, this is where I need you guys to really pay attention. Slow down, watch me, and really pay attention to the process. So first of all, it asks us what types of angles are angles CFD and EDF. So CFE is this angle right here. So it's asking me what kind of relationship does that angle have to EDF. And EDF, I'm going to go here, EDF is this angle right here. Well, hopefully you can see because this side is parallel with this side and that this line in here is a transversal, that those angles would be congruent. So that means this one down here is 21 and they would be congruent because they're alternate interior angles. Again, pay attention to the fact that they're on alternate sides of the transversal and inside the parallel lines. So they're alternate interior angles. Okay, so now we want to work through this drawing. I'm going to go ahead and erase these lines a little bit so that you guys can see. So we did say that that was 21 and this was 21 because they're alternate interior angles. So let's see what other, we have this other piece of information down here. It tells us that angle FED is 134. FED is that whole angle where E is. So that's 134, which means this opposite angle up here at C is 134. Then recall we can find F and D by subtracting 134 from 180 because consecutive angles are supplementary. So that means that when I subtract 134 from 180, I get 46 out here. So this is 46 and this is 46. Now you should be able to see that we have parts of some angles. So we can use the angle addition postulate basically. So notice out here that we have that the whole angle is 46 and part of it's 21. So to get this part right here, we would subtract 21 from 46. So that means this part right here is 25 and its alternate interior angle over here would be 25. Down here at the bottom, we have a similar situation. So notice here that this angle right here is 71. That means this angle up here is 71, because again, they're alternate interior angles. And we have that the whole angle is 134, so we would subtract 71 from that to get the other part of that angle. So that would make this 63 degrees, which means its alternate interior angle up here would be 63 degrees. Now I want to bring something else to your attention. When you are looking through these triangles, or these parallelograms, we're going to have 4 triangles here. Notice that. Now, we just learned in the last unit the triangle sum theorem. So when I add 63 plus 21, that gives me 84. Well, to find this angle right here, to find that angle right there, I would subtract 84 from 180. And that angle would be 96 degrees. So this angle right here is 96 because it's a vertical angle to that one, and that one's 96. Then we could find the other angle in here, this one right here. We could find this one by doing the same thing, adding 71 to 25 and then subtracting that from 180. Or I could just subtract 96 from 180, and that's 84 degrees. So that would make this angle right here 84 and this angle right here 84. So now we have every angle in the drawing, and now we just have to find them to put them on the line. So let's look at DEC. So D is out here. DEC. DEC is that angle right there. So that's 63 degrees. Then we have CDE. So I'm going to use a different color so that we can see it. CDE. Notice that's the whole angle. So that's going to be 46 degrees. Then we have EDC. Let's find EDC. E is down here. D is out here. Oh, sorry, EC. Sorry, my bad. EC. So it's ECD. So ECD is this angle right here. That's 71 degrees. Last one we have is DFE. So DFE is, let me pick a different color. I know this is getting confusing. DF is right there, and E is down here. So we're talking about this angle right here, 25 degrees. It's going to take a little practice, guys. So don't give up, but work through the examples. Okay, now let's look at number 4. I'd like you guys to try to do number 4 yourselves. Sorry, number 5. Yourselves, and then come back to me when you're done. Okay, so I'm just going to label the stuff that's here right now. So we got X, Y is 15, and if that's 15, then this over here is 15 because opposite sides are congruent. Then we have WX is 22, so if WX is 22, then ZY is 22. Then we have that ZX is that diagonal, and it says it's 32. So I'm going to do 32 divided by 2. That will give me 16. So that means this right here is 16, and this right here is 16. 16 plus 16 is 32. Then we have WT is 10. Well, if that's 10, then I know my other part of my diagonal is 10. So we could go ahead and answer this first part of the question, where it has ZW is 15. We have that ZY is 22. We have that TX was 16, and WY was 10 plus 10, which is 20. Now let's talk about angles. I'm going to go ahead and erase all of this stuff just so you guys can see it a little clearer on my drawing. All right, so let's go ahead and label what we have for angles. So it says WZY, WZY, WZY is this angle out here. So this would be 62 degrees out here, which means its opposite angle would be 62 degrees. And I also could find W and Y because that W and Y would be 180 minus 62. So this angle up here would be 118 degrees for the whole thing, and this would be 118. Now let's label some other things that we're given. WXT. WXT is this angle right here, WXT. So it's this angle right here. It says it's 27 degrees. Then we've got ZWT. ZWT is this angle right here, and this one is 77 degrees. Now, we know that these guys have some alternate interior angles to them. So I'm going to go ahead and erase these lines. Actually, I'm going to re-put these in here. So again, this was 77, and this one over here was 27, right? 27 here, yes. Okay. So the alternate interior angle to the 77 is this one over here because they're on alternate sides of that transversal. And the 27 would be down here because it's on the alternate side. Now I want you to notice that this whole angle up here is 118. So to find this part right here, we would just subtract 77 from 118. And that's 41. So down here, its alternate would be 41 down here. Here again, we've got the whole angle is 62, so we would subtract 27 from the 62. So that gives us 35 here, which means this one over here would be 35 as well because they're alternate interior angles. Now what you should be able to see is we have 2 of 3 angles in all our triangles. So we can now find the values. So see this triangle right here? So we would add 41 to 27. That would be 68. And then we would subtract that from, yeah, was that right? Yeah, 68. We would subtract that from 180, and that would give us, I can't read my handwriting, that's pretty sad. So this would be 41 plus 27, that's 68. We would subtract that from 180. So, sorry, subtract. I'm tired today, y'all. 180 minus 68, that would be 112. So that means this angle right here is 112, and its vertical angle would be 112. And because we just did it right there, we also know that this is 68 and this is 68. So, for the measure of angle TZY, let's see if we can find it. T is in the center, Z is down at the bottom. So TZY is that angle right there, so that's 27 degrees. So this one's 27. Then we have XYZ. XYZ would be that whole angle right there, so that's 118 degrees. Then we have XWT. XWT, let's do this in a different color. XWT is right there, so that's 41 degrees. And then our last one is XYT. Where's our X? So XYT would be this one right here, so that's 77 degrees. And again, probably the hardest part of these lessons is finding the angles. Pretty sure you guys can work through the drawings to find this stuff. But so now we're going to work number 6. Go ahead and do that and then come back to me when you're done. So I'm going to work through this one, and this one is all about angles. So we've got GHF, GHF, GHF is that angle right there, so that's 34, which means this down here is 34. Then we have HJF, HJF, this is 134 out here, which means this is 134 out here, and it also means I can find H and F by subtracting 134 from 180. So H and F are 50. Wait, did I do that right? Sorry, that's supposed to be 124, y'all. my bad, 124 and 124. So we're going to subtract 124, sorry, from 180. And that would be 56 up here and 56 down here. So then we also have FKJ. FKJ is right there. So this is the one that it says it's 79 degrees. So that's that one right there. Okay, so now there's a variety of things we could find and some things that we can start with. So notice down here we have this 34 and the whole angle is 56. So we could subtract 34 from 56 and that would give us 22 here for this angle, which means this one up here would also be 22. And then we have that this one's 79 here, which means its vertical angle here is 79. We can also find the angle that's beside it, the linear pair, by subtracting 79 from 180, so that would make this 101 and this one 101. Now you should be able to begin to see that we have two angles in several triangles, so we can find by the triangle sum theorem. So let's look down here. Do you see this triangle right here? Hopefully you see this one. We have 34 and 79, so we would add 34 to 79 and then subtract that from 180. So that tells us that this angle right here is 67, which means this one up here is 67 because they're alternate interior angles. And then we could subtract the 67 here from the 124 there. And so this other angle right here is 57 degrees, which means its alternate interior angle up here is 57 degrees. Now we have all the angles in the drawing, so all we have to do is write the answers down on the lines. So GJF, again, let's see if we can work through this together. GJF is sorry, where's F? Oh, here. GJF is this one. So we're talking about this angle right here. So, sorry, I started with the wrong one. GFJ. Whoo! GF, where's F? Oh, down here. GFJ is that whole thing, right? So that's 56 out here. JGH. JGH is this one right here, 67 degrees. Then FGH. Let me do this in a different color. FGH is that whole angle up there. That's 124. Then we got FGJ. So again, let's pick a different color. I'll do red. FGJ comes down here. So that's this angle right here, which is 57 degrees. Then we have HFJ. So HFJ is going to come across the center. So we've got HFJ. That's this one down here, which is 34 degrees. Then we've got FHJ. So this one's FHJ, this one right here. That's 22 degrees. Then we have HKJ. So HKJ is this angle right here, which was 101. Then our last one is GJF. GJ is right here. GJF right there is, again, 67 degrees. I think I had that one on there twice, but that's okay. So then we're going to go on to number 7. Number 7, on this one, these are parallelograms, so we know the opposite sides are congruent. So we're just going to set these equal to each other. Going to subtract 5x from both sides. That gives me 4x. Going to add 25 to both sides. That gives me, 32. And then 4 goes into 32 8 times. So x equals 8 here. And the way we could check that is by plugging it back in and making sure that the opposite sides are congruent. Number 8, again, our opposite sides are congruent. We're going to set these equations equal to each other. So once again, 11 from 19 is 8. So that's going to be 8x. We're going to add 31 to both sides. So that's going to give me 32 here. 8 goes into 32 4 times. So x is equal to 4. This problem asks us to find yz. So we're going to do 19 times 4 minus 31, and that was 45. And again, when we plug it back in over here, when we do 4 times 11, that's 44 plus 1 is also 45, and it should be congruent because they're opposite sides. Number 9 says TV is 74 and WV is 4x. So we know that TV and WV are congruent. So we should be able to take this 74 and divide it by 2, and that gives us 37. So that means this length here is 37 and this length here is 37. So then we can set VW equal to that. So 37 is equal to 4x plus 1. So that would be 36 equals 4x. So x is equal to 9. Number 10. This one says NS and SQ. These are congruent because, again, they bisect. So we can set these equal to each other. 2x plus 7 equals 5x minus 23. Subtract the 2x from both sides. That gives me 3x over here. Add the 23 to the 7. That's going to give me 30. So x is equal to 10. And again, this is asking us to find NQ. So if we find NS, that's going to be 2 times 10 plus 7, which is 27. And then SQ should be 27 as well. 5 times 10 minus 23, that also is 27. So we're just going to add those two together to get the whole length, which is going to be 54. Number 11 says find the measure of angle B. So again, here, we know that these angles are congruent because they're opposite angles. So we can say 4x plus 11 equals 6x minus 15. Subtract the 4x from both sides. That gives us 2x. And then add the 15. That's going to give us 26. So x is equal to 13. Then we plug that x back in. So we can plug it back in for either one of the angles. So we could say 6 times 13 minus 15. That gives us 63 degrees. So this angle down here is 63, and this one up here is 63. So then if we're actually looking for B, we're going to do 180 minus 63, and that should be 117. So number 12 is different only because these are consecutive angles. So we are going to say that angle P plus angle Q equals 180. So that's what we're going to do. 3x plus 5 plus 8x minus 12 equals 180. Going to combine our like terms. That's going to give us 11x minus 7 equals 187. So 11x is equal to that should have been 180. Sorry, I just jumped ahead. It's going to be 187, and so x goes in there. 11 goes into 187 17 times. Then we're going to plug that back in, and we're going to look for. It's asking us for r, so I'm going to find p, and the reason I'm doing that is because p is congruent to r, right? So the measure of angle r is going to be the same. So we're going to do 3 times 17 plus 5 So that's going to give us 56 degrees. All right, so number 13. This one says if the measure of KLH, that's this angle out here, is 134, solve for x. So what we know, again, is our consecutive angle. So angle K up here is going to be 134 subtracted from 180. So this is going to be 46 degrees up here. Now we also know that if this is 25 over here, this is 25 right here. So we can add these two angles together right there, and they'll equal this whole angle. So that's going to be 4x plus 9 plus 25 equals 46. So that's going to be 4x plus 34 equals, wait, is that right? Yeah, 46. We're then going to subtract the 34 from the 46, so 4x equals 12, so x equals 3. Here again, it asks us to solve just for x, not to plug it back in, so we could if we needed to, but it just asks us to solve for x. Last one is number 14. So this time it tells us ABC, that's this whole angle up here, is 115 degrees. And once again, we have our alternate interior angles. So we know that this one right here is going to be 6x minus 11. So we can add those two together and they should equal 115. So we can say 4x plus 6 plus 6x plus 11 equals 115. So 4 plus 6 is 10, so we got 10x, and then we've got plus 17 equals 115. Wait. It was a minus 11, wasn't it? Let me fix that. My bad. So it was 6x minus 11 equals 115. So this is going to be 10x minus 5 equals 115. So that's 10x equals 120 because I'm going to add that 5 to both sides. So x equals 12. Then we have to plug that back in, and we're looking for ADB. ADB. So we're looking for ADB is this angle right here, this one. So we're going to plug it back in that equation. So 6 times 12 minus 11 is 61 degrees.